class, we are going to discuss another chemical property of an acid and a base. Let us know what happens when few granules of a metal is added to an acid or a base. Let us first try to understand what happens when metal is added to acid. So, we take hydrochloric acid. Let us suppose 10 ml of hydrochloric acid we take in a test tube. To that hydrochloric acid, we add few granules of zinc. That means a metal. Then what happens? So there will be reaction, there will be a chemical reaction between the hydrochloric acid and the zinc metal. Now a gas will be evolved from the test tube. What gas it is and how to find? Let us find out experimentally. Here in this test tube, I have took 10 ml of hydrochloric acid. To this hydrochloric acid, so here are the granules of zinc. So this is zinc. These are the granules of zinc. So these few granules of zinc now I am adding to this hydrochloric acid. Now observe carefully what will happen. See how it is reacting. If we put a matchstick here, you might have observed. So this is the reaction between metal and an acid. So in this reaction, hydrogen gas is evolving. Now let us write this reaction in the form of an equation. So here we have took hydrochloric acid and a metal, zinc. So hydrochloric acid, the formula is HCl, and it is reacting with zinc metal, gives rise to what will form? Here the hydrogen gas has been evolving. That means this zinc metal replaces hydrogen in HCl. Then zinc chloride will form in the test tube and hydrogen gas will be evolved from the test tube. So zinc chloride. This is an imbalanced chemical equation. Now we have to balance. See, here we have only one hydrogen, but here we have two hydrogens. So that's why we have to write 2 here. That means we have to take 2 moles of hydrochloric acid to do this reaction. Now the equation is balanced. So here HCl is taken in the form of aqueous. So that's why we have to write in aqueous form. Zinc is in the solid state. And zinc chloride, which is formed in the test tube, it is also in the form of aqueous. And this is hydrogen is a gas. So this is the chemical equation which shows the reaction between an acid and a metal. So in this reaction, hydrogen gas is evolving. How to find the released gas is hydrogen. So to test this, we have to do a small test. Just before you might have observed in the experiment. We have to take a burning matchstick in front of the test tube. Then the matchstick will burn with a pop sound. So you might have observed the pop sound in front of the test tube. So this is the test to find either the evolved gas is hydrogen or not. And one more important point to remember is this is an exothermic chemical reaction. That means in this reaction some amount of heat energy will be released.
Same like that, when a base reacts with a metal, it also releases hydrogen gas. Here we have took sodium hydroxide and it is reacting with zinc to form sodium zincate and to liberate hydrogen gas.
In this class, we are going to discuss another chemical property of an acid or a base. So here we are going to discuss the reaction between an acid and a carbonate or hydrogen carbonate. That means if you take sodium carbonate, that means 0.5 grams or half gram of sodium carbonate in a test tube. To this sodium carbonate, we need to add 2 ml of hydrochloric acid or any acid. So we take hydrochloric acid. What happens? That means when we are taking half gram of sodium chloride, sodium carbonate in a test tube, to this we are adding 2 ml of hydrochloric acid. Then the reaction takes place between the sodium carbonate and the hydrochloric acid. What will form? What will be the product? So after the chemical reaction between these two, we can find a gas will be evolved from the test tube. What gas it is? Let us try to do this experiment. So this is sodium carbonate. See how it is looking. So half gram of sodium carbonate we have to take in a test tube. Let us take. So we have took approximately half gram of sodium carbonate in this test tube. To this, now we have to add 2 ml of hydrochloric acid. This is diluted hydrochloric acid, not concentrated. So to this we are adding diluted hydrochloric acid. See here a gas is releasing. So to test this we have to take lime water. This is lime water dipped tube. Now I am putting this here in front of the mouth of the test tube. Now let us observe how the dipper has been changing. See, observe. So this has been changed to milky white color. That means the lime water has been changed to milky white in this reaction. Which gas do like this? Obviously the carbon dioxide. The carbon dioxide converts lime water into milky white color. So in this chemical reaction, carbon dioxide gas is evolving. To write this chemical reaction in the equation form. First we have to sodium carbonate. So Na2CO3 is the formula of sodium carbonate. To this sodium carbonate, we have added diluted hydrochloric acid. What will form here? So here, sodium chloride will form. And also water and also carbon dioxide gas. Actually, this is an imbalanced chemical equation. We have to balance it. See, in the reactants, there are 2 sodiums given. But in the products, there is only 1 sodium. That's why we have to take 2 moles here. Now, sodiums have been balanced. And also here, in the reactants we have only one hydrogen atom. In the products we have two. That's why we have to take 2 moles of hydrochloric acid. Now the chemical reaction is balanced. So here, same like that. Here we have done reaction between a carbonate and an acid. Instead of this carbonate, we can also take hydrogen carbonate. That means sodium hydrogen carbonate and an acid. How will be the reaction? Same like that before. So here also sodium chloride will form, and also water, and also carbon dioxide gas. So like this, when we react a carbonate or hydrogen carbonate with an acid, carbon dioxide gas will be evolved. How to test this carbon dioxide? To test this carbon dioxide, we have to take lime water. So this carbon dioxide converts lime water into milky water. How it changes? What is the chemical reaction between lime water and carbon dioxide? Let us try to know. So the chemical formula of lime water is calcium hydroxide. So this is lime water, and this lime water is reacting with carbon dioxide gas. What will form here? So here the calcium carbonate precipitation, white precipitation will be formed. So the white precipitation which is forming here is calcium carbonate and water. So this is the chemical reaction between the lime water and the released carbon dioxide gas. In this reaction, white precipitation will form. That white precipitation is calcium carbonate. In this class, we discuss about neutralization reaction. First, we take some basic solution in a test tube. So here, if you observe in this test tube, I have took some sodium hydroxide. To this sodium hydroxide, now I am going to add few drops of methyl orange. So this is the methyl orange solution. Now this methyl orange solution I am going to add to this sodium hydroxide solution, that is base. What is the color change in the basic solution? In the previous class we have already discussed it. That means when methyl orange is added to a basic solution, its color changes to yellow color. Now, now to this yellow colored solution, I am going to add few drops of acid. That means any acid you can take. To this solution, I am going to add few drops of hydrochloric acid. I will take few drops of hydrochloric acid in the so here I have took some hydrochloric acid. Now I am going to add this hydrochloric acid to this yellow colored solution. Observe carefully how the color changes. So gradually we have to add few drops of acid to this basic solution. And we have to observe the color variation in this test tube. See, the yellow color is gradually vanishing. If you observe carefully, the yellow color in the test tube is gradually vanishing. And if you observe carefully, in this test tube, a precipitation has been formed. That means if we put this test tube for some time, so here we can find out the formation of a precipitation. This is called a salt. That means the basic solution has been neutralized by adding acidic solution. So to this sodium hydroxide, we have added few drops of hydrochloric acid. Then in this test tube, a salt has been formed, and also water you can absorb. You can observe the water at the bottom of the test. Clearly, the salt and water formed in this neutralization reaction. Here you can find out the salt precipitation, and here you can find out the water. So in this neutralization reaction, salt plus water has been formed. Try to find out, let us try to write the chemical reaction, chemical equation between an acid and a base. So when base is added to an acid, what will form? A salt and water. So this is the skeleton equation of neutralization reaction. Now let us take an example equation for this. So for a base, we take sodium hydroxide. And instead of acid, we take hydrochloric acid. Gives rise to sodium chloride will form plus H2O, water will form. So this is the skeleton equation for neutralization reaction, and this is an example for neutralization reaction. Same like that, let us try to find out what happens when a metallic oxide is added to an acid. Let's try to find out the skeleton equation here. When a metal oxide is added to acid, what will form here? So in this chemical reaction also, salt and water will form. Observe these two chemical equations. So here in the neutralization reaction, base plus acid gives rise to salt plus water. In this reaction, metal oxide plus acid gives rise to salt plus water. By observing these two chemical equations, we can easily find out, we can easily say that the nature of the metal oxide is base. That means all metallic oxides are basic in nature. What are metallic oxides? Let us take few examples of metallic oxides. That means magnesium oxide, zinc oxide, iron oxide, aluminium oxide. So these are all few examples for metallic oxides. All metallic oxides are basic in nature. So by this we can easily conclude that the nature of the metallic oxides is a base. Same like that, if we take non-metallic oxide, how it will be? When non-metallic oxide is added to a base, salt and water will form here also. So observe this reaction and this reaction. So here the reaction between non-metallic oxide and a base to form salt and water. So by observing these two chemical equations, we can say that the nature of the metallic oxide is acidic nature. So by this we can easily conclude that non-metallic oxides are basic in nature. Metallic oxides are basic in nature and non-metallic oxides are acidic in nature. What are the examples for non-metallic oxides? Non-metallic oxides, for example, carbon dioxide, carbon monoxide, nitrogen oxide, nitrous oxide, sulfur oxide. These are all examples for non-metallic oxides. So by these two equations, we can easily conclude that the nature of metallic oxide is basic nature, the nature of non-metallic oxide is acidic nature. So this is about neutralization reaction. Let us try to know how to dilute an acid. So basically, there is a confusion, little bit of confusion. Either we want to add water to acid or acid to water. So here, we should not add water to acid directly. Why? When water is added to the acid directly, so a large amount of heat energy produces and the flask will break down. That's why we should not do like that. Then how to dilute? We have to take water in a flask. So here you might have observing a flask. This flask is called as conical flask. These type of flasks are called as conical flasks. So in this conical flask, what we have to do? We have took some water. So into this water, what we have to do now? In this dropper, I have took some acid. Now, how to dilute? We have to drop acid dropwise. That means observe carefully. I am releasing only drops of acid. So after releasing some drops of acid, we have to shake the flask thoroughly. Again, we have to add few drops of acid. Again, we have to thorough the flask thoroughly. So same like that, by adding drops of acid, we have to shake the flask thoroughly. So like this, we have to dilute an acid. In this class, we discuss about neutralization reaction. First, we take some basic solution in a test tube. So here, if you observe in this test tube, I have took some sodium hydroxide. To this sodium hydroxide, now I am going to add few drops of methyl orange. So this is the methyl orange solution. Now this methyl orange solution I am going to add to this sodium hydroxide solution, that is base. What is the color change in the basic solution? In the previous class we have already discussed it. That means when methyl orange is added to a basic solution, its color changes to yellow color. Now to this yellow colored solution, I am going to add few drops of acid. That means any acid you can take. To this solution, I am going to add few drops of hydrochloric acid. I will take few drops of hydrochloric acid in the so here I have took some hydrochloric acid. Now I am going to add this hydrochloric acid to this yellow colored solution. Observe carefully how the color changes. So gradually we have to add few drops of acid to this basic solution, and we have to observe the color variation in this test tube. See, the yellow color is gradually vanishing. If you observe carefully, the yellow color in the test tube is gradually vanishing. And if you observe carefully, in this test tube, a precipitation has been formed. That means if we put this test tube for some time, so here we can find out the formation of a precipitation. This is called a salt. That means the basic solution has been neutralized by adding acidic solution. So to this sodium hydroxide, we have added few drops of hydrochloric acid. Then in this test tube, a salt has been formed, and also water you can absorb. You can observe the water at the bottom of the test. Clearly, the salt and water formed in this neutralization reaction. Here you can find out the salt precipitation, and here you can find out the water. So in this neutralization reaction, salt plus water has been formed. Try to find out, let us try to write the chemical reaction, chemical equation between an acid and a base. So when base is added to an acid, what will form? A salt and water. So this is the skeleton equation of neutralization reaction. Now let us take an example equation for this. So for a base, we take sodium hydroxide. And instead of acid, we take hydrochloric acid. Gives rise to sodium chloride will form plus H2O, water will form. So this is the skeleton equation for neutralization reaction, and this is an example for neutralization reaction. Same like that, let us try to find out what happens when a metallic oxide is added to an acid. Let's try to find out the skeleton equation here. When a metal oxide is added to acid, what will form here? So in this chemical reaction also, salt and water will form. Observe these two chemical equations. So here in the neutralization reaction, base plus acid gives rise to salt plus water. In this reaction, Metal oxide plus acid gives rise to salt plus water. By observing these two chemical equations, we can easily find out, we can easily say that the nature of the metal oxide is base. That means all metallic oxides are basic in nature. What are metallic oxides? Let us take few examples of metallic oxides. That means magnesium oxide, zinc oxide, iron oxide, aluminum oxide. So these are all few examples for metallic oxides. All metallic oxides are basic in nature. So by this we can easily conclude that the nature of the metallic oxides is a base. Same like that, if we take non-metallic oxide, how it will be? When non-metallic oxide is added to a base, same, salt and water will form here also. So observe this reaction and this reaction. So here the reaction between non-metallic oxide and a base to form salt and water. So by observing these two chemical equations, we can say that the nature of the metallic oxide is acidic nature. So by this we can easily conclude that non-metallic oxides are basic in nature, metallic oxides are basic in nature and non-metallic oxides are acidic in nature. What are the examples for non-metallic oxides? Non-metallic oxides, for example, carbon dioxide, carbon monoxide, nitrogen oxide, nitrous oxide, sulfur oxide. These are all examples for non-metallic oxides. So by these two equations, we can easily conclude that the nature of metallic oxide is basic nature, the nature of non-metallic oxide is acidic nature. So this is about neutralization reaction. Hi everyone. In the previous classes, we have discussed about the various properties of acids, bases, and also we have discussed about neutralization reaction. And now, in this class, we are going to discuss what is an acid and what is base. How can we say that the solution is acidic or basic? Why a solution must be acidic, basic or neutral? To find this, we need to know few more things. That is, let us take a water molecule. That means in every solution, the content of water is present. Let us take the dissociation of water molecule. See, the formula of water molecule is H2O. When this H2O water molecule dissociates, it forms H plus ions and also OH minus ions. That means hydrogen ions and also hydroxyl ions. Then this hydrogen ions react with another water molecule to form H3O plus ions. This ion is called as hydronium ion. This is So this H3O plus ion is called as hydronium ion. So in a solution, the number of H plus ions is always equals to number of H3O plus ions. So in the deciding of a liquid, either it is acid or base, the concentration of H plus ions or H3O plus ions is important. That means Thus, the acidity or basicity of a liquid or a solution depends on the concentration of H plus ions or H3O plus ions. Hydrogen ions or hydronium ions. Here, to find the Strength of a liquid or the strength of acidic nature or basic nature. A scientist called Sorensen, he prepared a scale, a pH scale. That scale is called as pH scale. In that pH scale, the range is between 0 to 14. Here you can observe the pH scale. So in this pH scale, the range starts from 0 up to 14. So in these 14 divisions, so mid one is 7. This 7 indicates neutral. And from 0 to less than 7, these values indicates the acidic nature. And from greater than 7 to up to 14, these values indicate the nature of basic nature. So this basic nature or is also called as alkaline nature. Basic nature or alkaline nature. Now, let us try to find how to find the pH value of a solution. In the laboratories, we have pH paper. So that pH paper, if we dip in any liquid, suppose we have a solution in a flask. If we dip that pH paper into that flask, if the color of the pH paper changes to red color, so if the color of the pH paper changes to red color, so its pH value must be between 0 and 2. So that means it is highly acidic liquid, highly acidic solution. Suppose if we dip a pH paper into a solution, the color of the pH paper changes to pink color. Then what will be the pH range of that solution? So it may be between 3 to 5. So if the color of the pH paper changes to pink color, its pH value is between 3 and 5. That means it is weak acid. If we dip the pH paper into the liquid, its color changes to yellow, its range will be between 6 to 7. That means it is very weak acid. And now, if the pH paper, the color of the pH paper changes to green color, then what will be the pH value of that solution? The pH value is almost equal to 7 or 8. That means it is neutral solution. Then, if the color of the pH paper changes to blue, its pH range is between 8 to 10. That means it is a weak base. If its color changes to indigo color, its pH value is between 10 to 12. That means it is moderately high basic nature. If its color changes to violet color, then it is a strong base. It is a strong alkaline. So, like this, by using pH paper, we can find out the pH value of the given solution. So here, from 0 to 7, these solutions are called acidic solutions. The pH range from 7 to 14, these solutions are called basic solutions or alkaline solutions. The solution having exactly 7 pH value is a neutral solution. For example, water is a neutral solution. Its pH value is almost equal to 7. And also blood, the pH value of a blood is almost equal to 7. So that is also a neutral solution. And now let us discuss how the strength of acid or the strength of a base changes or increases. Just before we have discussed that in a solution, H plus ions or OH minus ions are present. That means if the concentration of H plus ions or H3O plus ions, that means hydrogen ions or hydronium ions. So if the concentration of hydrogen ions is greater in a solution, it must be an acid. That means the solutions having pH value 0 to 3, these solutions have more hydrogen ions concentration or more hydronium ions concentration. As the pH value increases, the hydrogen ion concentration decreases. As we reach to 6 or 7 pH value, the hydrogen ion concentration almost decreases. And the solution having 7 pH value, in it the hydrogen ion concentration is almost equal to the hydroxyl ion concentration. That means H plus ion concentration and OH minus ion concentration are almost equal in the neutral solutions. That's why in water the hydrogen ion concentration is equals to the hydroxyl ion concentration. As the pH value again increases from 7 to 14, the hydrogen ion concentration decreases almost and hydroxyl ion concentration increases. That means the OH minus ion concentration increases from the pH value 7 to 14. The solutions having 13 or the solutions having pH value 13 or 14, they have very high concentration of hydroxyl ions. That means OH minus ions. That's why the solutions which have the pH value of 13 or 14 are highly basic nature solutions. So these are the few important things that we need to remember in pH scale. Now, let us discuss what is the importance of pH in our daily life. First, we know that the pH value of rainwater is almost equal to 7. That is, the pH, that means the nature of rainwater is neutral. But due to acid rains, the pH value of rainwater decreases. That means it becomes acidic. So when this acid rains, that means when the water of acid rain flows into the rivers or oceans, the pH value of water reduces. That means it decreases from 7 to 6 or 5 like that. When this pH value of water decreases below 5.6, then what happens? See, the aquatic life which is underwater, so it is very difficult for them when the pH value is less than 5.6. That's why we have to control the air pollution. Because of air pollution, the acid rains we are facing. That's why for the survival of aquatic life, we have to control the air pollution. Then the acid rains will automatically control it. And what is the next one? So basically, we may have heard the word tooth decay. When this happens, when our tooth become decay, that means, see, after taking food, so when the pH value of mouth decreases because of the food particles. So when this pH value of mouth decreases less than 5.5, the bacteria which is present in the air, it produces some acids in our mouth. So this acid makes our tooth become decay. That's why we have to brush our teeth twice a day. So when this toothpaste we use, that means the toothpaste contains basic nature. That's why when this basic nature toothpaste we use, the acids produced in our mouth, these will be balanced. That means these will be neutralized. So by this we can protect our teeth from tooth decay. And another important impact of pH in our daily life is indigestion. That means when we are facing indigestion, the pH, the acids will be released from our stomach. So we know that in our stomach, the hydrochloric acid will be released for the digestion of our food. When this hydrochloric acid is released from the stomach, it is helpful in the digestion of the food. But in the cases of indigestion, this acid remains in our stomach. So it produces irritation and also pain in our stomach. So to overcome this pain or to overcome this irritation, we have to use some mild bases like milk of magnesia, that is magnesium hydroxide. So these bases are called antacids. That means to avoid acidic nature, that means to avoid acidity or to avoid indigestion, we have to use mild bases called antacids. Same like that, when the honeybee stings on our skin, so these honeybees release formic acid into our skin. This formic acid is also called as methanoic acid. So when this formic acid or methanoic acid enters into our skin, it creates irritation or pain on that place. To avoid this, we have to use some bases immediately to get rid of that pain. Hi everyone. In this class, we are going to discuss about another concept of acids, bases and salts chapter, that is water of crystallization. Let us discuss about this topic. Before that, let us know about a salt copper sulfate. We know that copper sulfate is in blue color because every copper sulfate molecule contains some water molecules. That means every copper sulfate molecule is attached with 5 water molecules. That means the formula of copper sulfate is, so every copper sulfate molecule is attached to 5 water molecules. That's why the color of copper sulfate is in blue color. If we heat this copper sulfate, then what happens? Let us try to do this experiment. Here you can observe copper sulfate in this cap. So this is in blue color. Now I am taking some copper sulfate into this test tube. So in this test tube, I have took some copper sulfate crystals. Now I am going to heat this test tube here. Observe carefully what happens here. So while heating, the color of copper sulfate changes. That means the copper sulfate which is in blue color, it is changes to white color. Let us observe this after heating a while. Observe the test tube here. So on the top of the test tube you can observe some water droplets. So from where these water droplets have came? So the copper sulfate which is in the test tube, after heating, the water molecules from this copper sulfate, these have been evaporated and these are the water molecules evaporated from the copper sulfate. You can observe at the bottom of the test tube, the color of the copper sulfate has been changed from blue color to white. Why the color has changed? Because the water molecules present in the copper sulfate, they have been evaporated. That's why the color of the copper sulfate has changed to white color. If we add few drops of water to this copper sulfate, again the blue color regains. That means if we add few drops of water to this copper sulfate, it will get its original color. That means blue color. Let us try to add few drops of water to this test tube. Now, let us add few drops of water to this test tube. Observe what happens to this copper sulfate. See, if you observe carefully into this test tube, the white color is gradually disappearing. So, after some time, when the water molecules attach it to this copper sulfate, it will become blue color again. See, observe carefully how the color of the copper sulfate changed. The copper sulfate again, the white colored copper sulfate again regained its blue color. That means this copper sulfate having water molecules, after heating it will evaporate. Then the color of the copper sulfate changes to white. After heating that, if we add few drops of water, the white colored copper sulfate again regains its original color, that is blue color.
Hi everyone. In this class, we are going to discuss about some common salts. They are bleaching powder, baking soda, washing soda, and plaster of Paris. Let us discuss one by one. First of all, let us discuss about bleaching powder. Its formula is CaOCl2. Bleaching powder is produced by the action of chlorine on dry slaked lime. The formula of slaked lime is CaOH taken twice. So here is the equation. So when calcium hydroxide, that is slaked lime, reacts with chlorine, then we can produce bleaching powder, that is CaOCl2. Let us try to know the uses of bleaching powder. So it is used for bleaching cotton and linen in the textile industries. And also we use this bleaching powder to wash clothes in laundry. It is also used as an oxidizing agent in many chemical industries. It is also used for disinfecting drinking water to make it free of germs. That means to kill germs, we add bleaching powder to the water. So we use this bleaching powder as a reagent in the preparation of chloroform. Chloroform is one of the chemical compound we use in laboratories and also some industries. Let us discuss about another salt, baking soda. The formula of baking soda is NaHCO3. Baking soda is sometimes added for faster cooking. It is prepared as follows. So here is the chemical equation which shows the preparation of baking soda. So here we have took sodium chloride, water, carbon dioxide and ammonia. Then we can get ammonium chloride and also baking soda, that is NaHCO3. The following reaction takes place when baking soda is heated during cooking. So here is the chemical equation. 2NaHCO3 gives rise to Na2CO3. that is sodium carbonate, plus water plus carbon dioxide. That means basically in the preparation of cakes or breads, we add baking soda. That's why when baking soda is heated in the ovens, it releases carbon dioxide gas. This carbon dioxide gas makes the cake or bread spongy and soft. So this baking soda, that is sodium hydrogen carbonate, is also used as a mild antiseptic. Let us learn about another salt, that is washing soda, and its formula is Na2CO3 10H2O. That means each sodium carbonate molecule is attached with 10 water molecules. By heating baking soda, we obtain sodium carbonate. That means when we heat baking soda, that is sodium hydrogen carbonate, we can find sodium carbonate. We use this in glass, soap, and paper industry. It is used in the manufacture of sodium compounds such as borax. Borax is a chemical compound which we use for cleaning objects, or it is used basically in the laundries or somewhere like that. It is used to clean the stains on the cloth. It is used for removing permanent hardness of water. So water has two types of hardness, temporary and permanent hardness. So to remove permanent hardness, we use this washing soda. Let us learn about another common salt, that is plaster of Paris. Its formula is CaSO4 half H2O. By heating gypsum at 373 Kelvin, we can prepare plaster of Paris. Simply we call it as POP. See, the formula of gypsum is given here, CaSO4 2H2O. It is also called as calcium sulfate hemihydrate because each water molecule is attached with two calcium sulfate molecules. That's why we call this plaster of Paris as calcium sulfate hemihydrate. So generally doctors use this as a plaster for supporting fractured bones. When bones are fractured, so this plaster of Paris is used to make it normal. Plaster of Paris is a white powder. On mixing it with water, it sets into hard solid mass due to formation of gypsum. That means when this plaster of Paris is mixed with water, it will form a hard substance called gypsum. Here is the chemical equation which shows this. So when calcium, that means plaster of Paris, CaSO4 half H2O, is mixed with 1.5 water molecule, we can find gypsum, that is CaSO4 2H2O.